Hello everyone. Today we will study integration by partial fractions. This is an important technique for integrating rational functions. So let's see some questions. Question 1. Evaluate integration of 2x plus 1 over x plus 2 into x minus 3. So this is a rational function here. So here we try to split this given function into two parts. For that, let us write the given function, that is 2x plus 1 by x plus 2 into x minus 3. So here we will try to break this function into two parts. So here we will first write the two expression from the denominator, that is x plus 2 and x minus 3, and here we will assume any number a and b. So let this be equation 1, and we try to find the value of this a and b. So in this way we will split the given function. So here this equals to, here if we take the LCM of these two denominator, then we will have x plus 2 times x minus 3, and on top we will have a into x minus 3 plus b into x plus 2. Since the denominators are same, so the numerators should also be equal. So this implies 2x plus 1 equals to a into x minus 3 plus b into x plus 2. Or you can think this denominator has been cancelled. Now since my aim is to find the value of a and b, so for this we will first put the value of x equals to minus 2 in this equation, because if I put the value of x equals to minus 2, then here in the second expression, that is b into x plus 2, here it will be minus 2 plus 2, which will make this expression 0, and after that it will be easier to find the value of a. So let us put x equals to minus 2 here, then we will have 2 into minus 2 plus 1 equals to a into minus 2 minus 3 plus b into minus 2 plus 2. So this part becomes 0. This implies minus 4 plus 1 equals to minus 2 and minus 3 is minus 5a, implies minus 3 by minus 5 equals to a. So the value of a is 3 by 5. Let me consider this equation as 2. Now in order to find the value of b, we put x equals to 3 in this second equation, because on doing so, then this term, that is a into this, will be 3 minus 3, which will make this term 0, and it will give the value of b. So let us put x equals 3 in equation 2, then we will have 2 into 3 plus 1 equals to a into 3 minus 3 plus b into 3 plus 2. So this implies 3 2 is 6 plus 1, that is 7, equals to, this part is 0 and 3 plus 2 is 5, b, implies b equals to 7 over 5. Now since we got the value of a and b, we will put this value in equation 1. So putting the value of a and b in equation 1, then we have equals to, putting the value of a as 3 by 5, then it will be 3 by 5 into 1 over x plus 2, plus putting the value of b as 7 by 5 here, then it will be 7 by 5 into 1 by x minus 3. Now the given function has been splitted into two parts, and since we have to integrate this function with respect to x, so integrating this function means to integrate these two terms, so equals to 3 over 5. Now integration of 1 over x plus 2, since this is a linear polynomial, so I will assume this to be as x, and integration of 1 over x is log of x, so we will have log of x plus 2. And actually we have to divide this integral with the derivative of that x plus 2, and since the derivative of this x plus 2 is 1 only, so here at denominator we will have 1 only. So I prefer not to write that here, plus 7 by 5. Similarly here it's in the form of 1 over x, and since there is a linear polynomial, so this will also be log of x, and the derivative of it is 1, so divided by 1 plus c. Question 2. Evaluate 2x minus 1 over x minus 1 times x plus 2 times x minus 3. So there are 3 factors getting multiplied in the denominator. So we have to split this function into 3 different terms. So let 2x minus 1 by x minus 1 into x plus 2 into x minus 3 be equal to a over x minus 1, the first factor, plus b over x plus 2 and c over x minus 3. So this implies, taking the LCM here, we will have x minus 1 into x plus 2 into x minus 3, and on numerator we have, since there is x minus 1 here and the LCM is this much, so here we have to multiply this a with x plus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x plus 2. Now since the denominator are same, so numerator should also be equal. So this implies 2x minus 1 equals to, and let us consider this equation as 1, a into x plus 2 times x minus 3 plus b into x minus 1 into x minus 3 plus c times x minus 1 into x plus 2. Now my aim is to find the value of a, b and c, and let this be equation 2. So put x equals to 1 in equation 2. On doing so, this term will be 1 minus 1, which will be 0. So this everything will be 0, and here also it will be 0. So we will only have a remaining. So putting x equals to 1 in this equation, then we have 2 into 1 minus 1 equals to a into 1 plus 2 into 1 minus 3. The second term will be 0 and the third term will also be 0. So on simplifying, we have 1 here equals to 2 plus 1 is 3 into minus 2, that is minus 6a. So from here we get the value of a equals to minus 1 by 6. Next we put the value of x as minus 2. On doing so, this first term and the last term will be 0. So put x equals to minus 2 in equation 2, then we will have 2 into minus 2 minus 1 equals to, this first term will be 0 because here as you see this minus 2 plus 2 will get 0 and this minus 2 plus 2 will also be 0, plus the second term, that is b minus 2 minus 1 into minus 2 minus 3, plus the third term will also be 0. So on simplifying, we have minus 5 equals to minus 3 and minus 5 will be plus 15b. So this gives the value of b equals to minus 1 by 3. Now in order to find the value of c, we put x equals to 3. On doing so, this 3 minus 3 will be 0 and here 3 minus 3 will be 0. So putting the value of x equals to 3 in equation 2, then we will have 2 into 3 minus 1 equals to 0 plus c into 3 minus 1 into 3 plus 2. So this will give 5 equals to 10c. So this implies c equals to 1 by 2. Now since we got the value of a, b and c, we put back these values in equation 1. So from equation 1 we have equals to, putting the value of a as minus 1 by 6, so we will have minus 1 by 6 into 1 over x plus 1, sorry minus 1, minus 1 by 3, putting the value of b, and putting the value of c as 1 by 2, so this function has been splitted into 3 parts. Now since we have to integrate the given function with respect to x, so to integrate this means to integrate the 3 terms with respect to x. So this equals to minus 1 by 6, integration of 1 over x minus 1 will be log of x minus 1 minus 1 by 3 into log of x plus 2 plus half into log of x minus 3 plus constant of integration. Question 3. Here let us assume cos of 2x equals to t. Differentiating, we get minus 2 sin 2x dx equals to dt. This implies sin 2x dx equals to minus 1 by 2 dt. So the given integral I will be equal to integration of sin 2x dx is minus 1 by 2 dt over 1 minus t into 2 minus t. Now here we will use the technique of partial fraction. For that, let the function is now 1 by 1 minus t into 2 minus t equals to, let us suppose a over 1 minus t plus b over 2 minus t. So let this be equation 1. So this implies, taking LCM, we have 1 minus t into 2 minus t, and on numerator we have a into 2 minus t plus b into 1 minus t. Now since the denominator are same, the numerator should also be same, implies 1 equals to a into 2 minus t plus b into 1 minus of t. Now to get the value of a, let us put t equals to 1, then this gives 1 equals to a into 2 minus 1 plus this second term will be 0 if I put t equals to 1, and this implies a equals to 1, and let us put t equals to 2 in equation 2, implies 1 equals to the first term, that will be 0 plus b into 1 minus of 2. So this implies b equals to minus 1. Now since we got the value of a and b, let us put these values in equation 1. Putting back the value of a and b in equation 1, then we have 1 over 1 minus t into 2 minus t equals to a is 1, and since b is minus 1, so here it will be minus 1 by 2 minus t. Therefore my integral I will be equal to minus 1 by 2 is there outside integration. So from here we can write this as 1 by 1 minus t minus 1 by 2 minus t dt. Now Let us split this. It will be integration of 1 by 1 minus t dt minus integration of 1 by 2 minus t dt. So this equals to minus 1 by 2. Integration of 1 over 1 minus t is log of 1 minus t at first, but since I always say that we have to actually divide the answer with the derivative of the function which we considered as t or x. So here the derivative of 1 minus t is minus 1, that's why here we have to divide minus 1 minus, similarly here it will be first log of 2 minus t, and the derivative of 2 minus t is minus 1, so here it will be minus 1 plus c. So opening the bracket with minus half, we will have 1 by 2 log of 1 minus, putting back the value of t, that is cos of 2x, minus 1 by 2 log of 2 minus cos of 2x plus c. Question 4. Evaluate 3x minus 2 over x plus 1 whole square x plus 3. Here note that there is x plus 1 and whole square. So in this type of function, we will assume the given function to be a by x plus 1, the first term, and the second term we will assume the square of same expression. So since there was x plus 1 whole square, so if there is whole square, then we have to assume in this manner. At first term we will write x plus 1 only, and in the second term we will write x plus 1 whole square, and obviously for x plus 3 there should be the separate term. So let that term be c over x plus 3. So let this be equation 1. This implies 3x minus 2 over x plus 1 whole square equals to, taking the LCM here, we have x plus 1 whole square into x plus 3. Because the LCM of x plus 1 and x plus 1 whole square is x plus 1 whole square only. So on the numerator we will have a into, see, in the LCM there is x plus 1 whole square, and in the denominator of a there is x plus 1 only. So here we have to multiply with x plus 1, and there is x plus 3 also, plus b into, since the denominator of b is x plus 1 whole square and the LCM is x plus 1 whole square into x plus 3, so here we have only x plus 3 plus c into x plus 1 whole square. So comparing the numerator, it will be 3x minus 2 equals to a into x plus 1 into x plus 3 plus b into x plus 3 plus c into x plus 1 whole square. So let this be equation 2. Now let us put x equals to minus 1 in this equation 2, then we will have 3 into minus 1 minus 2 equals to, this first term will be 0 because minus 1 plus 1 will get 0, so this is 0, plus b into minus 1 plus 3 plus the third term will also be 0 because on putting the value of x minus 1, this term will also be 0. So on doing so, we will have minus 5 equals to 2b. So this implies the value of b equals to minus 5 over 2. Now let us put x equals to minus 3 in equation 2. So this gives 3 into minus 3 minus 2 equals to, this term will be 0 because minus 3 plus 3 will be 0, and the second term will also be 0. So we will have 0 plus c into minus 3 plus 1 whole square. So this gives minus 11 equals to 4c. So this implies c equals to minus 11 by 4. Now we have to find the value of a, but here if you see, we cannot directly find the value of a by putting the value of x in the equation 2. So for that we will continue expanding this equation 2 and we will compare left hand side and right hand side in order to find the value of a. So here it will be 3x minus 2 equals to a into x plus 1 into x plus 3 is x square plus 4x plus 3 plus bx plus 3b plus c into x plus 1 whole square is x square plus 2x plus 1. Now rearranging the terms on the right hand side, then we will have a plus c x square plus 4a plus b plus 2c into x plus the constant terms, that is 3a plus 3b plus c. Now since we have to find the value of a, so comparing the coefficients of x square on the left hand side and the right hand side, then we will have a plus c equals to 0, because there is no x square term in the left hand side. So that means the coefficient of x square is 0 in the left hand side. That means this a plus c should be equal to 0. So here comparing the coefficients of x square, then we will have a plus c equals to 0. And since we have the value of c as 11 minus 11 by 4, so we will put it here. So this implies a, the value of c is minus 11 by 4 equals to 0, and hence the value of a equals to 11 by 4. Now let us put back the value of a, b and c in equation 1. Then we will have equals to the value of a is 11 by 4 into 1 over x plus 1. The value of b is minus 5 by 2 into 1 over x plus 1 whole square, and the value of c is minus 11 by 4 into 1 over x plus 3. And since we have to integrate this function, so to integrate this means to integrate these three terms. So here it will be the first term 11 by 4 log of x plus 1, and the derivative of x plus 1 is 1, so we will not write that 1 in the denominator. And the integration of this second term, note there is x plus 1 whole square, so you do this by the method of substitution only. Then here we will have minus 5 by 2, and if I integrate this, then we will have minus 1 over x plus 1 minus 11 by 4. Here it will be log of x plus 3 plus c. Hence the answer will be 11 by 4 log of x plus 1 plus 5 by 2 into 1 over x plus 1 minus 11 by 4 log of x plus 3 plus c. Question 5. Evaluate integration of 2 over 1 minus x into 1 plus x square. Here if you notice, then the second expression is a quadratic. So in this type of case, we will assume the given function as for the first expression, we will consider a by 1 minus x, plus for the second expression, that is 1 plus x square, which is quadratic, we assume a linear on top of it. So we will assume a linear on top of quadratic. So let this be equation 1. So this implies equals to, the LCM will be same, and on the numerator we will have a into 1 plus x square, plus here it will be bx plus c into 1 minus x. This implies 2 equals to a into 1 plus x square plus bx plus c into 1 minus x. Let this be equation 2. So at first let us put x equals to 1 in equation 2. On doing so, we have 2 equals to a into 1 plus 1 square is 1, plus this second term will be 0, because if I put the value of x as 1 here, this will be 0. So due to which this entire term will be 0. So this implies 2 equals to 2a, and hence a equals to 1. Now again, to find the value of b, we will continue expanding equation 2. So here this implies 2 equals to a plus ax square plus bx minus bx square plus c minus cx. So rearranging the terms, we will have a minus b x square plus b minus c x plus a plus c, which is constant. So let us compare the coefficients of x square. So the coefficient of x square is a minus b here, and on the left hand side there is 0. So therefore a minus b equals to 0, and since the value of a is 1, we have got, therefore the value of b is also equal to 1. Now to find the value of c, let us compare the constant term, that is a plus c, and here the constant is 2. So a plus c equals to 2, and since the value of a is 1, therefore the value of c is also equal to 1. Now let us put the value of a, b and c in equation 1. 2 by 1 minus x into 1 plus x square equals to the value of a is 1 by 1 minus x, plus the value of b is 1. So here it will be x plus c is also 1 by 1 plus x square. Let us split this also into two parts by splitting the denominator, plus x over 1 plus x square plus 1 over 1 plus x square. So to integrate this function means to integrate this, integrating this and integrating this. So the integral of this first term will be log of 1 minus x, and the derivative of 1 minus x is minus 1. So here we have to divide minus 1, plus the integral of this second part will be 1 by 2 log of 1 plus x square. Here you can do this by assuming this x square to be t, that is by the method of substitution. And the integral of the third part is tan inverse of x, because this is in the form of a square plus x square, that is our special integrals which we have learned in the previous videos, plus c. Question 6. Evaluate integration of x square plus 1 over x square plus 4 into x square plus 25. So here at first we will just assume this x square to be another variable. So let us assume this x square to be y. We are not doing the substitution, okay, just assuming x square to be y. Then the given function, that is x square plus 1 over x square plus 4 into x square plus 25 equals to y plus 1 divided by y plus 4 y plus 25. Now we will use the partial fraction here. So let us assume this y plus 1 over y plus 4 into y plus 25 equals to a by y plus 4 plus b by y plus 25, and let this be equation 1. So this implies equals to y plus 4 into y plus 25, and in numerator we will have a into y plus 25 plus b into y plus 4. Comparing the numerators, then we will have y plus 1 equals to a into y plus 25 plus b into y plus 4. Let this be equation 2. So first let us put y equals to minus 4. On doing so, we will have minus 4 plus 1 equals to a into minus 4 plus 25, and the second term, that is this, will be 0. So this implies the value of a equals to minus 1 by 7. Put y equals to minus 25 in equation 2, which gives minus 25 plus 1 equals to, this term will be 0 as minus 25 plus 25 is 0. So 0 plus b into minus 25 plus 4. Now this will give b equals to 8 over 7. Putting the value of a and b in equation 1, we will have equals to minus 1 by 7 into 1 over y plus 4 plus the value of b is 8 by 7 into 1 by y plus 25. And since the y was x square, therefore x square plus 1, putting back the value of y, by x square plus 4 into x square plus 25 equals to minus 1 over 7 x square plus, let us write this 4 as 2 square plus 8 by 7, 1 by the y is x square and 25 is 5 square. Now since we had to integrate this function with respect to x, so it will be this much. So this equals to minus 1 by 7. Now this integration of 1 over x square plus a square is from the 9 special integrals which we had discussed in the previous video. So from that, this will be 1 by a, that is 1 by 2, into tan inverse of x by a, that is x by 2, plus 8 by 7 into 1 by a into tan inverse of x by a plus c. So it equals to minus 1 by 14 tan inverse of x by 2 plus 8 over 35 tan inverse of x by 5 plus c. So that's all for today's lesson. Thanks for watching, and in the next video we will be starting definite integral.